All right, pre-cal. This is our last example in 9.3. We're still in our vector unit, still looking at speed and direction. So we have an airplane flying with an airspeed of 310 knots and a heading of 50 degrees. That's a true bearing, not a quadrant bearing. If a 78 knot wind is blowing from a true heading, so this is a true heading of 125, determine the speed and direction of the plane relative to the ground. So that means we're looking for the resultant. So of course we're using this relationship right here. So I'm going to start with the airplane. It's going to be V, so this is going to be V right here. So I've got to find my direction angle. So I am going to start here. A 50-degree heading means that right there. All right, because remember we start north and go clockwise for true bearings. So that's what that would look like. That means the direction angle is going to be 40 degrees because it starts positive x and goes to the vector. So V is going to equal 310 knots times the cosine of 40 degrees. 310 times the sine of 40 degrees. So the airplane's original velocity vector is this right here. And now we're looking at the wind. All right, so again, the wind, I'm told, has a true bearing of 125. So that's going to be right here. So quadrant 1, 90 degrees, and then 35 degrees to give me a total of 125 degrees. So we need to know, of course, the direction angle. So let me switch colors here. The direction angle, remember, is going to be from here all the way around to the vector. So that means 3 quadrants. So 270 plus this little angle right here. Well, there's 90 degrees, remember, in a quadrant. I know I didn't draw this to scale, so I'm sorry about that. But this is going to be 55 degrees. So when I add 55 degrees, I get 325. So for the wind, I have, what's our speed? It is 78 knots times the cosine of 325 degrees. Then, of course, I just type these separately into my calculator, and I get 63.9 and negative 44.7. And then, of course, I have to find this relationship. So R is equal to 237.5 and 199.3 plus 63.9 and negative 44.7. So this plus this gets added together, and I end up with 301.4. This and this add together. Notice this is a negative, so I get 154.6. Okay, now I'm going to use this to find the direction and the speed. So the speed is going to be the square root of each of those squared and added together. I don't know why I put that in parentheses, but that's okay. 338.7 knots. That's the speed. That's one of my answers. And now I'm going to use this and this. So positive 301.4, positive 154.6. There's my right triangle. Tangent theta equals opposite over adjacent. Hypadjacent. Wow, Miss Griggs. Out of control. And then, of course, tangent inverse of all that. And we get theta at 27.2 degrees. So that is this angle right here. So what I have to do is I have to get a... my direction can be a true bearing or it can be a quadrant bearing. Since we're in quadrant 1, the true bearing is going to be the same just without the quadrant directions. So this right here I get from subtracting 27.2 from 90 degrees. So this is 62.8 degrees. So north, 62.8 degrees east, that's a quadrant bearing, or you can just write it as a true bearing, which would be 62.8 degrees. Either one, fine with me. Knock yourself out.